Good evening everyone and welcome to the third video in the Eigenvalues and Eigenvectors series. In the first video we had introduced ourselves to the concept of eigenvalues and eigenvectors, and in the second video we had seen how to find out the characteristic polynomial for a 2 by 2 matrix. In this video we are going to find out the characteristic polynomial of a 3 by 3 matrix. We have a matrix A here which has entries 4, 1, minus 2, 1, 2, minus 1 and 1, 1, 0, and we are going to find out the characteristic polynomial of the matrix A. Let us get started. So we know that the characteristic polynomial is a polynomial in lambda given by C of lambda is equal to determinant of A minus lambda I, where I is the identity matrix having order same as that of A. So first let us find out A minus lambda I. So A minus lambda I will be 4 minus lambda, 1, negative 2, 1, 2 minus lambda, negative 1, 1, 1 and 0 minus lambda, that is negative lambda. In the second video we had seen that A minus lambda I affects only the diagonal values and not the non-diagonal one. So determinant of A minus lambda I is going to be the determinant of the matrix which we have just constructed. So 4 minus lambda, 1, negative 2, 1, 2 minus lambda, negative 1, 1, 1 and negative lambda. So let us start with A11 entry which is 4 minus lambda, and the corresponding minor matrix is this, whose determinant is minus 2 lambda plus lambda squared plus 1. Then the next entry is 1 and the corresponding minor is this. So we have minus 1 minus lambda plus 1. And for the last one, A13 element is negative 2 and this is the corresponding minor. So we get minus 2 into 1 minus 2 plus lambda. Let's simplify. So this is 4 minus lambda. Rewriting this in order, we get lambda square minus 2 lambda plus 1. Simplifying this, we get plus lambda minus 1. 1 minus 2 is minus 1. And we will simplify this, so we get plus 2 minus 2 lambda. Let's work on this. So we are getting 4 lambda square minus 8 lambda plus 4. Then multiplying negative lambda, we get minus lambda cube plus 2 lambda square minus lambda. Over here we have lambda minus 2 lambda, that's minus lambda, and minus 1 plus 2, that's plus 1. Going on further, we have negative lambda cube, then we have quadratic terms. So this is 6 lambda square. We have linear terms, minus 8 lambda, minus lambda and minus lambda, that's negative 10 lambda. And lastly we have 4 and 1, so that's 5. So thus we have the characteristic polynomial of matrix A is nothing but negative lambda cube plus 6 lambda square minus 10 lambda plus 5. As an exercise to this in continuation, I want to find out the characteristic polynomial of the matrix B given as Feel free to comment your answer. Hope this video helps you. Thanks for watching till here and do subscribe my channel and press the bell notification for more updates. Thank you so much once again and happy learning.